Your lovely video. You wanted me. Let me just make sure it's recording. Okay, we're good. Hopefully you can hear me because I have my fancy headset on. All right, so the first thing you want to make sure that you know are the formulas. So the formula for area of an equilateral triangle is a new formula. So what you do is you take 1/4 times √3. Make sure you close off that parenthesis before you multiply by the side of the rectangle or triangle squared, whatever the side is squared. Okay, that's the formula. Area of a polygon is 1/2 times the apothem times the perimeter. All right, so this is the apothem. I showed you what that was. That's the segment that's perpendicular to one side, and then the P stands for perimeter. All right, that's the perimeter of the polygon. Okay, and regular means all the sides are the same. All right, so the first question is this. This is the side of an equilateral triangle. Okay, so it's like that first formula. So it's 1/4 times √3 times side squared. Be really careful when you're trying to square all of this. Okay, so I don't know if you want to do it separate. If you know that this is really 64 times 2, which is 128, you can do that and then plug that in instead. Or just make sure you're using enough parentheses to square the entire side. So when I put that in my fancy little dancy calculator, 1/4 times √3 times, oops, I gotta make sure I close it off when I do the √3, times 8√2, close, squared. I get 55.4. Since it is areas, it should be units squared. All right, this is a square. First off, the central angle is found by taking 360 divided by the number of sides. So since it's a square, it has 4 sides, so that central angle is 90. Remember I said the central angle goes, like the radius touches a corner, the apothem goes to half the side. So that central angle is that whole thing. So for this case, I'm not going to need to divide, but half of the central angle would be 45. So this would be 45 degrees inside here. But we're actually, I kind of do need it to find the one side. Anyway, all right, this is the apothem. It's already been given to you. So there's nothing to do, but then write down the 5. All right, for one side, this is opposite of the angle. So this is O and this is A. That's adjacent. Adjacent, apothem, they have the same letter. All right, we're not going to use the hypotenuse in this case. So O and A is tangent. So for one side, we're going to use tangent of 45. That is going to equal O over A. Right? And that's not a 0. That's the opposite side. I guess I should do OP. Okay, when the variable or the unknown is in the numerator, we multiply both sides. So 5 times tangent of 45. When I do that, 5 tangent of 45, that gives me 5. Remember, that's just half of the one side. You need to multiply that by 2. So that gives me 10. So one side of my square is 10. It's a square. It's regular. The definition of a square is it has 4 equal sides. So the perimeter is going to be 40 because 10 times 4 is 40. For the area, we just plug in the apothem and the perimeter into my formula. So 1/2 times 5 times 40 gives me 100. 100 centimeters squared. I guess I should label my stuff. All right, that's how we do that. Now, I did do this one for you. You saw this one already, so I can run through it again. 360 divided by 5 tells me, 72 is my central angle. But remember, this is half of that, so that's 36 degrees. Okay, this is my A. This is my opposite. That's going to be my hypotenuse. The apothem was cosine of 36 is equal to a over 7. 7 times cosine of 36 is going to give me the apothem. I don't have to do anything times that. I don't have to do anything else to that. That's what I meant to say. So the apothem is 5.7. All right, now the one side, remember, this is half of the one side. So when you do it, whatever number you get, you have to multiply it by 2. So sine of 36 is equal to opposite over 7. When we multiply, whatever we get, we're going to need to times that by 2. So I get 4.1. Well, 4.1 times 2 is 8.2. It's a pentagon. It's regular. All the sides are the same. 8.2 times 5 is 41. Right? Now it's the easy part. 1/2 apothem times perimeter. Oh, I think I even put one on your paper. All right? So 1/2 times the apothem times the perimeter. All right, I got 116.9. I feel like I had something different on your paper, but at any rate, that is what it is. All right, and we're just going to keep repeating this, okay? So notice you're given the one side. So make sure you're looking at it. There, it's already given. You're also given the apothem, okay? The central angle, that's not too bad. You count your sides, 1, 2, 3, 4, 5, 6. Well, 360 divided by 6 is 60. All right, the perimeter, since you already have the one side, is 18 times 6. That's 108 meters. Oh, meters. And now it's the easy part. 1/2 times the apothem. Now be careful how you put that in. Make sure you close out that parenthesis times the perimeter. All right, so 1/2 times the apothem. Sorry, I'm having problems putting in my calculator. Times the perimeter. I got 841.8 meters squared. All right, this is a regular octagon, right? So that's telling me it has 8 sides. 360 divided by 8 is 45. All right, that's the central angle. I need half of that. 45 divided by 2 is 22.5. All right, now they gave me the apothem. I already know it. That's 6. I don't know the one side, right? So this is opposite. So when I'm given the apothem, which is A and O, I'm going to use tangent. So for the one side, this time I'm going to use tangent. So tangent of 22.5 is equal to O over A. So op over 6. So 6 times tangent of 22.5 gives me 2.5. You know, I don't like how I wrote that. It looks messy. I got 2.5 when I round it. Okay, so remember, for one side, we're going to take 2.5 times 2. That's going to give you 5 meters for one side of the octagon. Okay, it's an octagon. 5 times 8 is 40. All right, now you got the perimeter. You got the apothem. The area is 1/2 times the apothem times the perimeter. I believe that's 120 meters squared. But let me put it in my calculator here. Sure is. Nailed it. All right. Oh, here we go. Area of an equilateral triangle. This is the same paper that you have. All right. 1/4 √3 side squared. That's the area. So 1/4 times √3. Close it off times 5 squared. I get 10.8 inches squared. Nailed it. All right, another square. They didn't give us any information, but the central angle, 360 divided by 4, is 90. Okay, so you know this is half of that. So this is 45 degrees. This is my A. This is my op. The apothem, we're going to use cosine because it's adjacent. And 8 times cosine of 45 just gives us the apothem. So that's 5.7 when I round. Is this the same freaking one? Anyway, I feel like I am going crazy. All right, for the one side, I'm going to use sine opposite hypotenuse. So sine of 45 is equal to op over 8. And 8 sine of 45 is 5.7. Now remember, because it's only half of the one side, we have to take 5.7 times 2. And that's 11.4. All right, now all the hard work's done. Perimeter, it's a square, 11.4 times 4 is 45.6. Now my formula, 1/2 apothem times perimeter. And I get, well, it rounds up all the way to 130 inches squared. Because I did get 129.96. And that makes that go up, which makes this go up. So you know. All right. All right, here we go. We got a pentagon. You know, pentagon has 5 sides. 360 divided by 5. 72. This is half of that. 72 divided by 2 is 36. All right, here is A. Here is my opposite. To find the apothem, we use cosine. All right, 15 times cosine of 36 gives me the apothem right away, which is 12.1. All right, one side, we use sine. And 15 sine of 36 is 8.8. Remember, that's half of the one side. So you have to multiply. 8.8 times 2. 17.6. All the hard work is over now. The perimeter, it's a pentagon. One side times the number of sides, 88. All right, now we plug it into the formula. 1/2 times the apothem, which is 12.1 times the perimeter, gives me 532.4 feet squared. Sorry, I didn't label my thing. My goodness, none of them are labeled. That's just horrid. Horrid, horrid. All right, rinse and repeat. Hey, it's a regular hexagon, but look what they gave us. They gave us one side. They gave us the apothem. Oh, what a gift this is. So, and there's, 10√3 centimeters. One side, 20 centimeters. It's a hexagon, which means it has 6 sides. So 20 times 6 is 120 centimeters. Central angle, 360 divided by 6 is 60 degrees. Oh my God, we didn't even need to do, there was no hard work involved at all. You just need to be able to identify, if you see the box, that is the apothem. All right, if the line goes to a corner, it's a hypotenuse. All right, so 1/2 apothem times perimeter. Now I would want you to be very careful about this. When you plug in 10 root 3, make sure you close it off. So 1/2 times 10 root 3, close it off, times 120, and I get 1,039.2 centimeters squared. All right, that's it for that one. All right, it's a regular octagon. They didn't give us one side, but they gave us the apothem. This is the apothem. All right, for the central angle, it's an octagon. It has 8 sides. 360 divided by 8. 45. Remember, we need to split that. So that makes this 22.5. Okay, apothem given. Love it. One side. Now, when you're given the apothem, that's when you use tangent. So tangent of 22.5 is equal to opposite over adjacent. So 7 times tangent of 22.5, and we're going to round. That gives me 2.9. Remember, we need to multiply that times 2 because that's only half of the one side. I get 5.8 meters, degree. All the hard work's done. It's an octagon. One side's 5.8. Because it's regular, so are all the other sides. So the perimeter is 46.4 meters. And 1/2 times the apothem times the perimeter. And we are done. (162.4 meters squared). All right, arc length corollary. This is a formula. It's a proportion. Arc length over circumference is equal to, which, just so you know, the reference for the circumference is 2 pi r, right? That's the formula that goes here. It's equal to the measure of the arc in degrees over 360. It's a proportion. Sometimes x is going to be the arc length. Sometimes x is going to be the circumference. Sometimes x is going to be the measure of the angle, the arc in degrees. So now the length of AB, right? Central angle, so that means this is 45 degrees, but I don't know the length. So x is the length over 2 pi r. And we simply cross multiply. So 360x is equal to, 2 times pi times 5 times 45. 1,413.7. Divide that by 360. X is equal to 3.9. This is not area, so it's just going to be the units, not square. Okay? So we're looking for the arc length. Here in number 12, we're looking for the circumference. This is the length. So length over circumference, right? Now I'm going to put an X there, is equal to 55 over 360. So 55x is equal to 6.5 times 360, 2,340. Divide by 55. Oh, messy handwriting. I get x is equal to 42.5. That is the circumference. Basically like the perimeter of the circle. All right. Oh, this is crazy. All right, I'm going to show you something real quick. If this is 225 degrees, this has to be what gets me to 360. So 360 minus 225 is 135. That's what this has to equal. So 2x plus 15 has to equal 135. So 2x equals 120. X is equal to 60. All right, we found x. Now, for y, this is the length. I'm just going to make this equal to x. Just let x equal this for right now. And we're going to set up a ratio, and then whatever we get for x, we're going to set it equal to that, and then divide by pi, hit enter, and then add 3, and we're done. All right, so since this is the length, let x equal length. So now we have x over 2 pi r, r is 8, okay, is equal to the measure of degrees. Remember, it's this measure, which was 135 over 360. I gotta scroll up a little bit. Sorry, guys. Oh, wow, that was too far. All right, cross multiply. Well, I get 360x, 2 times pi times 8 times 135 is a big number. All right, I'm going to abbreviate and see if it works out. If it doesn't, I would say don't round. All right, so for x, I get 18.8. If this equals x, if y minus 3 times pi equals x, and x is 18.8, I'm just going to do this. I'm going to take 18.8 and divide it by pi. So then I get y minus 3 is equal to, and then when this rounds all the way to 6, I add 3 to it, y is equal to 9. All right, so that was a little next level, but you can do it. I believe in you. I believe in you. I just use what's called substitution. I just let x equal all of this. That way I didn't have to put that in there. You know what I mean? And then I could work backwards afterwards. Hopefully that made a little bit of sense. All right, the length, baby. We're back to this Jimmy Jam. All right, that's going to be x over 2 pi r is equal to the measure of the arc in degrees over 360. The only one that's never going to change is that 360 in the denominator of the second ratio. All right, 2 times pi times 5 times 50 is 1,570.8. All right, and I divide by 360, and I get x is equal to 4.4. Okay, lovely. All right, now it wants circumference. So this is the length here. That's going to be the numerator. The numerator is always the length over the circumference. I'm going to put x because I don't know it. It's equal to 60 over 360. So 60x, 3.8 times 360 is 1368. Divide that by 60. And x is equal to 22.8. So the circumference is 22.8 meters. All right, that's it for that one. All right, here's another very similar to length. The only difference is area of the sector is the numerator now. And now the denominator is area of a circle, which is pi r squared, right? That's really what goes on there. Unless they're just looking for the area of the whole circle, you could put x there. And then it's the measure of the arc in degrees over 360. You guessed it right if you were thinking it. All right, so it's another proportion, just like length, only now it's area of a sector, okay? So They want to know what is the area of this shaded region. Sorry. So x over pi r squared, pi 3.5 squared is equal to 80 degrees over 360. All right, so I know when I cross multiply with x, I get 360x. I'm just going to put this all in my calculator when I multiply. So pi times 3.5 squared times 80. And I get 3,078.8. Divide by 360. And I get x is equal to 8.6. 8.6. Now it's area, so it's going to be units squared. All right, not complicated. It's just a proportion. Okay, this one is not going to be a proportion because what I want you to imagine is find the area of the whole circle. Oops, I did not mean to do that. Find the area of the whole circle, and we're going to subtract the area of the little circle. So area of big circle minus area of small. That's what we're going to do. So area of a circle, just for reference, area is pi r squared. This is a little tricky because just from here to here is 10, but this is 5. So now the radius of the big circle is 15 centimeters. You do need to pay attention to that, okay? So the area of the big circle is pi 15 squared. Now we're going to subtract the area of the little circle, pi 5 squared. You literally put it right into your calculator just the way it looks. So pi 15 squared minus pi 5 squared is 628.3. Now it is area, so it's 628.3 centimeters squared. All right, sorry for my scrolling. All right, again, not going to be a proportion, okay? It's going to be half big circle minus half small circle. That's how we're going to set this up. All right, so here's another goofy kind of thing. This picture is a little silly because see this hash mark here and this hash mark here? So it said from this to that was 19. So that means this to this is 19. And that means that the radius of the big circle would have to be twice that. So the radius of the big circle is 38 centimeters. So let's plug in what we got into our little formula. Half pi r squared, pi 38 squared minus half pi r squared, but now the radius of the small circle is 19. Right? When you plug that in your calculator, that is going to give you the area of the shaded region. All right, so half pi 38 squared minus half pi 19 squared. I get 1,701.2, and it is area, so it's going to be units squared. 1,701.2 centimeters squared. Sorry for my scrolling. I never know if there's more on this page or if I need to go to the next page, which is what I need to do. So let us look. Ooh, yowza. All right, this is such a crazy one. It's again half big circle minus equilateral triangle. Okay, so that's that new formula. Remember the formula for this is 1/4 root 3 sides squared. So let's first figure out the area of this triangle. I don't know if you noticed, this is the radius of the big circle. It's 2 centimeters. Guess what? This is also a radius. So this is also 2 centimeters. and 2 centimeters, and 2 centimeters. So the area of this triangle is 1/4 root 3, close it off, times 2 squared. All right, so 1/4 times root 3, close it off, times 2 squared. So I get 1.7 centimeters squared for the area of this triangle. Okay, so now I can just find half of the big circle minus that. I don't even have to use the formula. So half pi r squared minus 1.7. Donezo. So half pi 2 squared minus 1.7. I get 4.6. And again, we're talking about area, so it's going to be units squared. All right, it might look crazy, but really it's not that difficult. You're just subtracting out the white space in these type. You know, if it's not just that little wedge of a pie you're looking for, you have to just make an equation. All right, what else we got? Oh, that's it. All right, guys, well, that's it. I hope you've enjoyed this video, and I hope it gave you clarity, and maybe you, again, should watch it Sunday night before your big day, because Monday's your big day, okay? Okay, that's it. Bye.